Hi guys, this is a short video to recap some of the big ideas we learned in Module 2 to help prepare you for your semester final. I already have some notes written down here. This unit was a lot about equations, inequalities, and we also took what we learned about graphing transformations and applied them to absolute value. I do have one more thing to add here because I forgot to put it on here, was when we were solving compound inequalities. So I'm just going to put something in here. If we have the absolute value is less than a constant, what that turns into is this compound inequality. Negative c is less than x is less than c. If we have absolute value of something is greater than c, we get a different compound inequality. We get the same thing, x is greater than c, or x is less than negative c. So we're also going to be solving some inequalities in this unit that involve absolute value. Okay, so let's jump into some examples. You can pause the video and get those notes if you need to. Here, I'm going to write the equation of a line in slope-intercept form that is perpendicular to this line and has the same y-intercept as this one. So I have a couple of options here. I need two things. They want me to write my equation in slope-intercept form, which is y equals mx plus b. The easiest one to, well, I'll come back to that. Okay, so there's kind of two things I need. I need the slope and I need the y-intercept, right? Well, they want me to make sure the line's perpendicular to this one. So up here, my note that says perpendicular lines have opposite reciprocal slopes. So if this equation, this line has a slope of -1/4, the slope of a perpendicular, that's the symbol for perpendicular, would have to be positive 4/1 in order to make sure it's perpendicular to this one. So -1/4 and 4 are opposite reciprocals. Okay, now for the b, the y-intercept. They want us to have the same y-intercept as this line. So I can do this a couple ways. I could solve this equation for y and put it in slope-intercept form, or I also know that the y-intercept is always the coordinate when x is 0. So if I were to substitute 0 in for x and solve for y, that would give me the y-intercept. So 0 times 7 is just 0. So y then has to be -4. So that is actually my b. So if I know the slope and the y-intercept, I can write my equation. So I've got y equals 4x minus 4. That would be the equation of the line perpendicular to this line and with the same y-intercept as this one. Okay, so now we're going to do some solving of inequalities. So this inequality, I'm going to solve just like I would an equation. The only thing I have to keep an eye out for is when I multiply or divide by a negative, that's going to flip my inequality symbol. So I'm going to first get all my x's together. So I am going to add 5x here. So I have x plus 1 is greater than or equal to -6. I'm going to subtract 1. So I've got x is greater than or equal to -7. So it says solve and graph. So I am going to put this on a number line. So we've got the value -7. If it's a greater than or equal to, it's going to be a filled in circle. And the numbers greater than or equal to -7 are to the right. If it had just been greater than, this would have been an open circle, and less than, I would have shaded to the left with my arrow. Okay, next one, we have an absolute value inequality. Before I set up this, I have to get the absolute value piece by itself. So I am going to get rid of this 2 by dividing both sides by 2. So I have 3x plus 9 is greater than 18. Okay, so now this has this format. So I'm going to set up this inequality. So I have 3x plus 9 is greater than 18, just like it is, or 3x plus 9 is less than -18. And then I'm going to solve each of those. Okay, so we're going to subtract 9. So I've got 3x greater than 9, so x is greater than 3. This one, subtract 9, we got 3x is less than -27, so x is less than -9. Okay, my graph for this one then. So we have x is less than -9, so open circle, less than is to the left, and then 3, x is greater than 3, open circle going to the right. Okay, all right. Piecewise functions are something we looked at as well. So being able to write an equation for each of these pieces. In this unit, we just did linear, but we also have graphed quadratics later on in semester 1, so you could see a piecewise with quadratic or linear pieces. Okay, so linear. I want to be able to write my piecewise function. So basically what I'm trying to write is I'm trying to write mx plus b if it's a line. Okay, and then we have like the domain restrictions. Okay, so let's start with this. So if this line were going forever, right, if it crossed through the y-axis, my y-intercept would be 3. So I'm going to replace that guy with 3. The slope of a horizontal line is 0. So you could write this, you guys, but we don't typically write it like this, right? Because 0 times x is 0, and 0 plus 3 is 3. So I'm just going to write it as 3. Okay, now this line kind of falls apart. It breaks at a certain point. So that's this piece, that domain restriction. So where I want to look at that x value, where that happens, where does it end? So it ends when x is -1. So we know it's going to involve -1. Now my graph exists to the left of -1, which is less than -1. That open circle, I'm going to leave it just as less than, not less than or equal to. Okay? All right, so now we're gonna do the second line. So this b looks like it's 2.5, okay? -2.5, sorry. I'm gonna write it as a fraction. -2.5 is 5/2, okay? My slope, I'm gonna find some nicer points here. So here's my slope, I'm going down 1 and over 2. So -1/2 is my m. Okay, and this happens also that same breaking point when x is -1, but it happens to the right of -1. So that's when x is greater than -1. And because of that filled in circle, we're going to make it greater than or equal to. So that's kind of the process, is you find your slope and y-intercept and then look at that breaking point. Where does your graph stop? And that x value tells you how to write that domain restriction. Okay, last one here, you guys. Absolute value function, we're going to write a equation for this. So we have absolute value involving x. Okay, so things I want to look for: did it shift left, right, up, down? Did it reflect? And is the slope different? Because that would be a vertical shift, vertical stretch, excuse me. So my vertex is normally on 0, 0. So my vertex has gone right 2, right 1, and up 3. Okay, so that is going to affect my horizontal and vertical shifts here. So if I go right 1, I got to write -1 here. If I want up 3, I got to write up 3 there. Now my slope is still 1, so I don't have a vertical stretch, but it's facing upside down. It's been reflected, so I do need a negative in front of this. So that would be the equation that matches this graph. All right, that's it for the Mod 2 review.